Hello, everyone. Well, welcome to today's session on data-driven intelligence. We're going to focus on building AI solutions with Azure's data stack. And why this is important today is because as AI models have become emergent and become a critical asset to business operations, we need to shift our focus and the patterns in which we enable organizational growth. So we're going to talk through a bit about that today, and I'm glad for you to join me. As a quick introduction about myself, my name is Brett Decker. I'm a senior solution architect here at CoreTech. I've been in the industry for over 12 years and focusing on many different verticals like finance, healthcare, manufacturing, and many others. I've got a background in hands-on implementation, designing architectures, supporting solutions, consulting, and program development. I'm an industry speaker, as you see here in a webinar. I'm also husband and father and an automotive enthusiast. So today, we're going to focus in on data platforms, and we want to be able to trace the path from ingestion to insight. Where are we getting our data from? How are we using it in the Azure data platforms? And then how are we able to capture those insights and view or be notified about them? So we're going to spend the next 30 minutes, and we've got a few agenda items. First being the Azure AI Data Services overview, then designing a scalable data architecture for AI, integration across the Microsoft ecosystem, and then we'll wrap up with governance, compliance, and operations. So let's get started and jump into the Azure AI Data Services overview. The first thing that I always like to share with everyone, and to make sure everyone understands the gravity and importance of data in an AI ecosystem, is as we look at the components, we've got generative AI, cloud native apps, modern data platform, and then infrastructure. But as you can see here, generative AI components only make up 20 to 40% of a given AI workload. And so what that means is we have to pay extra special attention to those cloud native apps, that modern data platform, and the Azure infrastructure that supports it. And so how do we do that? Well, one of the first things that I always recommend, because data is so important to these AI solutions, is to perform a deep dive over the data that you have. Define what are those data source locations? Are they internal systems? Are they external APIs? Are we using financial management, inventory data? And let's begin to capture what are each of those different data sources that our solution is gonna use. And then what are the formats, right? Each of these data sources is gonna be made up of some type of format, and we're gonna need to map that to our AI agents and our AI workloads. And then most importantly is we'll need to evaluate the data quality and any gaps that we have in it. And as we start to think about that data quality evaluation, we really want to ensure completeness and accuracy of the data so that as AI is performing its analysis and doing the tasks that it's intended to, that it isn't using inaccurate data or missing data. And if it is, maybe that we fine tune the model to account for that. So as we dive in and double click onto the data quality evaluation, right, it's really made up of 4 key categories, right? That's completeness, right? Are all of the required fields populated, right? Maybe we're trying to analyze our Salesforce data and looking at customer records. But if some of the customers don't have records, how can we really get a good evaluation? Accuracy. Are maybe people putting in inaccurate data into one of our backends? And how can we then, from an organizational change management, help to address and correct that? The timeliness. Is our data current and up to date? Right? Sometimes for these real-time applications, I'll talk about financial services and fraud detection here, which is a very critical solution. What is the speed at which we can perform the analysis based on how fast we can collect that data? And then consistency. Is it consistent across platforms, or do we need to do some data engineering to make sure that we can align and associate records or data points within our environment? Right. And if we don't do this data quality evaluation, it can reduce the accuracy of our models. We can get incorrect insights and ultimately wrong decisions being made by the AI solutions. So, what are some of the tools that we can help to address these challenges and to allow us to have a seamless integration of our data with our AI agents? Well, Microsoft Fabric is one of the capabilities that you have in the Azure AI ecosystem. And Fabric specifically is an enterprise end-to-end analytics platform, unifying data movement, processing, ingestion, transformation, real-time event routing, report building across the various different components within your environment. Fabric, I see it as an umbrella. And historically, if you know Azure, you may have been familiar with services like Data Factory or Synapse, and even Power BI as a long-time service. And now Microsoft is bringing these tools all together into a single platform that allows us to have compute dedicated across the types of services that we're going to be leveraging. We've got consistent user interfaces, and we've got integration with things like Copilot so that we can get easier access to our analytics and build our environments faster. You can see here that it's built on a OneLake and a Microsoft Purview foundation, OneLake being a repository for us to house that data that we're going to unify across each of these services. And Purview then, the tool to help us govern that data and to be able to do classification and lineage over that. And we'll touch on each of those just a little bit more during this presentation. And so, what is OneLake? OneLake is the OneDrive for data, right? And it's an intelligent data fabric that allows us to then leverage all of our compute-based workloads and our data processing, data engineering, analytics within one platform and keep a single copy of our data. We can organize it into specific data domains, but ultimately we have one copy with one set of security controls that we can use to govern the entire ecosystem. So let's talk about an example. So we worked with many healthcare organizations, and specifically a customer of ours has developed in conjunction with Cortec a predictive patient risk modeling solution that allows us to identify high-risk patients early in their care journey and ultimately optimize the care pathway that those individual patients are taken down by the clinicians and the doctors. And we do that by leveraging a number of different services in the Azure platform. You'll see here some of our key technologies are Fabric, Azure Machine Learning, Power Automate, Microsoft Teams, Power BI, and these really help to stitch together a solution in which we can ingest data from an EMR like Epic using a Fabric data pipeline that brings it into our lakehouse. Remember our OneDrive for data. We can then aggregate it all together here so that we can perform analysis and predictive analysis using machine learning models. And so you can see as our data comes and flows into the lakehouse, we then have the Azure AI services for machine learning that house and contain multiple predictive models that can then compose those into an ensemble model for the optimal care pathway for that given patient. This data then gets sent through what's called an event lake, which can then pass those patient recommendations to multiple different locations in your environment. And the first one, Power Automate, being a solution that we can then send notifications in real time to our clinicians that leverage Microsoft Teams, and they'll be notified that, hey, you have a high-risk patient, and these are some of the recommended care pathways that you should take. And this may happen in real time while the patient is there attending for services. We'll also have Power BI that will take the data from our lakehouse and then make that available in a reporting dashboard for our administrators and our clinicians to look at, not just for an individual patient, but also to begin looking at a larger group of patients and doing predictive trend analysis on their solution and visualizations of those trends that they're seeing in the environment. And so the solution uses an API connection. It uses the Fabric foundation to then aggregate our data and make it available to our AI services that then we can provide notifications to our team, or we can provide reports that then everyone has visibility to. And so this is just one example of how that we can build a modern data ecosystem for AI agents within the Azure platform. But one other solution that I always like to make note of, and I'll give an example of a customer environment here in a few slides, is Azure Databricks. And Azure Databricks does have a number of similarities to Microsoft Fabric in that it contains a single copy of your data, and that it has many different capabilities like governance in the Unity catalog, which is an industry-leading governance solution for data in an environment. But it also has open storage formats where we can use the Delta Lake, the Apache Iceberg, Parquet, and host them on the data foundation within Azure. And so this is another great solution for data engineering within your environment. It does have a very high performance capability and something that is worth considering as you are looking at modernizing your data estate and comparing with other services like Microsoft's Fabric. So that was a little bit about the Azure AI data services. Now, let's talk a little bit about designing a scalable data architecture for AI. One of the first most important components that I see is organizational change management. The technology is a set of configurations that we'll have to design and determine together. But organizational change management can be much harder. And so as you look at a modern data warehouse adoption, we always recommend that you start with the data culture. It allows you to then move into a center of excellence. And that center of excellence can help to support and drive the data modernization and the new AI agents that you bring into your environment, and really enable organization adoption with mentoring, communities of practice, governance, oversight, and then really having that change management to continue collecting correct and accurate data in a timely fashion. And so as we think back to our data quality evaluation, these are all steps and components that are required to really get our data quality to the highest level. And so don't forget about organizational change management as you begin this journey. Now, we're talking about designing a scalable architecture. And the Lakehouse is one of the foundations of that scalable architecture. As I had mentioned earlier, OneLake within Microsoft Fabric provides a Lakehouse. And you'll see here that there's a fairly simple flow for the way that we can ingest and scale our data in the environment. We'll have things like structured or unstructured data that move into our environment with pipelines and data flows, and then live into a lakehouse that can then be transformed again to maybe a gold, silver, or bronze tier in your environment, and then exposed out to reporting solutions like Power BI, or maybe we just need to make a lake warehouse for it. And this pattern can be leveraged across multiple different technologies, but it is the core of Microsoft Fabric. We'll talk a little bit more about shortcuts here in a minute, but think about those as just another location for structured or unstructured data, really creating a symbolic link to that data so that you can easily store and transform and expose it. So I said I was going to give another example or an example here about Azure Databricks. And this is a manufacturing solution that we developed in partnership with a customer of ours for smart factory optimization. And the real key outcome here is that we improve the production efficiency and the predictive maintenance scheduling for the machines, PLC devices that manufacturing and assembly line have in place. And then enables us to make faster data-driven decisions about things like, hey, when should we replace the parts on this machine? Or are the tolerances of the products that we're developing within check? Or are there new configurations that may be needed for our PLC equipment or for the machines that we're operating in our environment? And so a very valuable solution when we consider that the lost production capability if these machines go down unexpectedly or produce incorrect parts is very high. And so this is a great hedge against those potential risks. Now, how do we do that? Well, using things like video feeds, the machine IoT sensor data, we bring that in through an IoT hub hosted in Azure. And that IoT hub then allows us to connect it to various services within our environment. Now, in this particular example, we're using Azure Databricks because of some of its great AI models that we can leverage, but IoT Hub can connect with Fabric as well. And so we have some similarities in the architecture of those solutions. And what you'll see here is that we follow a similar pattern with the pipelines moving into the lakehouse and having notebooks to be able to then transform and process our data. And you'll see here that we're leveraging an image model for the video feeds and a prediction model based on all of the sensor data and feed data that we're receiving. And so that's great. Once we're able to analyze this, where does it go from here? Well, we then send alerts out through an event hub that can then connect to Power Automate and Microsoft Teams, and then relay out to our floor supervisors what is happening with the equipment that we're leveraging in our production facility or our assembly line. And as well as provide Power BI reports to our maintenance team so that they can see, hey, I'm going to need to replace the parts for this well in advance, and so that they can reduce and schedule the time that their machines are down. And so leveraging things like this advanced IoT integration, being able to normalize the data and then notify based on it is very valuable for a manufacturing organization and our customer here. So this is an example of designing a scalable architecture. And another great point, and I was just mentioning earlier, is that shortcuts. They help us to virtualize the data across our domains. And so if you just kind of think about it as like a bookmark, we're saying, hey, we've got data over here, and we're still going to leverage it as a part of our analysis or as a part of our data engineering. And so then we can still consolidate our data access across workspaces within our environment while still keeping that granular access control, management, and governance over each of the individual data repositories. Maybe that's finance and services or business KPIs. And we can have them separate, but still linked and together as we perform reporting or processing on them. And as you can see here, and I'll mention a few other times, is that many of these tools have integrations with hybrid environments and that they can work in a multi-cloud scenario. And so it's very common for us to have a shortcut to virtualize a data link across to another cloud such as AWS. So as we're building the scalable AI agent ecosystem, what do we really need to think about as far as security? Well, we need to ensure that sensitive information is properly tagged and restricted to authorized users. We need to have clear policies around our data usage. This comes back to that organizational change management. We need to align our AI workloads with established detection, prevention, and response systems, just like we would many of our other IT solutions. We need to address evolving legislation, align with compliance frameworks, right, and train not just our technical teams, but our business stakeholders on what a secure AI solution looks like. And so those are very important factors in really being able to get a scalable solution in place. But let's talk a little bit about integration across the Microsoft ecosystem. So Microsoft is a strategic enabler of AI agents and data warehousing. And in order to properly govern, protect, and manage those, they have tools that are designed and tailored to be able to accomplish those goals, like unified governance with Microsoft Purview. And this is where we can centrally classify and label and manage the data lifecycle of any of the connected data, transformed data, or loaded within our environment. We've got that proactive threat intelligence with Sentinel, right? If we want to detect anomalies in real time, then we can do so. We want to manage, and as I mentioned earlier, an umbrella of our data environment, Fabric is a really great way to do that. And so this brings us to a key question. Are your current security measures flexible enough to support AI growth while still protecting your core assets? Because we need to be able to adapt and evolve very quickly, but we also need to ensure that we can keep security and governance in mind as we're doing so. Now, one way that Microsoft has provided a framework to adopt AI within the Microsoft ecosystem is the Responsible AI framework. And this provides a few different pillars of responsible AI usage, from fairness, right? Making sure that it's available and that we have mitigated biases within the environment. It's reliable and safe. It can be used by everyone. It's private and secure. And other large language models aren't training on our data, but it's inclusive and diversive. And so this will allow us to then build a trustworthy AI, right, that is required so that we can ensure long-term adoption and realization of our investment within the Microsoft space. And so as we start to think about, okay, we're going to develop an AI agent ecosystem with these data warehouses behind it. Um, well, what are all the different types of connections and services that I may use? Well, another great example here is a financial services solution in which we enabled fraud detection at scale, leveraging even generative AI models within the environment. And this is able to then detect anomalous behavior across multiple financial channels and identify those high-risk activities in near real time. You can see here we've got a few different data sources, such as documents that contain some of the logic and rules, an ERP system, and transactional API data that is ingested into our environment, not just with Fabric, but also with an Azure Event Hub that can then allow us to process incoming real-time transactions. Rather than having them run through any data pipelines or transformations, we can then send them straight to our AI agents, which are built in a container app environment. And so in this solution, we've got Fabric, we've got Azure AI Services here, including content understanding, Azure OpenAI, and then the Azure Container Apps that enable our multi-agent solution. Now, multi-agent solutions are very important as they also allow us to improve the consistency and accuracy of our responses. And you can see that here we have a data capture agent, a fraud anomaly detection agent, a large transaction agent, a duplicate transaction agent. And these are all leveraged in conjunction together with the data coming in from the Event Hub in order to then provide high priority alerts via an Event Hub out to Microsoft Teams and Power BI. And so this is very valuable in that we can get and detect and then mitigate the risk in near real time via notification to our compliance management team, while also allowing our banking managers to be able to see a long-term view of our risk profile and events that have occurred. So that's a great example of really tying a lot of the Microsoft ecosystem solutions together. Now, it's also important to note that OneDrive keeps that one copy for all of your different computes. And so whether you're using T-SQL or Spark, analysis services, otherwise, this really creates that real separation of compute and storage, where you can then connect multiple compute engines to your single copy of data that is managed and governed from a holistic capacity. And so this really allows for a dynamic build within your environment, and it separates that compute and storage between each other. And so when we think about building that resilient AI ecosystem, we want to have scalability and reliability to make sure that it can handle fluctuating demands. Potentially things like Azure Event Hub will allow us to do that. Security by design, using things like Sentinel and Purview built into our solution, streamlining our operations so that we can automate these routine tasks with AI agents while providing that trust that we have a responsible framework in place that everyone feels comfortable and confident using. And so let's move into our last topic for the day, which is governance, compliance, and operations. So I always like to think about governance, risk, and compliance as a series of risks in our environment that all come back to governing the AI ecosystem. And that includes prompt and response protections. What are our end users sending out? And what are they going to get back? Our infrastructure and platform protections. How are we securing the endpoints that we've established? The API and integration protections. If we're going to connect to external sources or we're going to expose ours, what do we need to do or account for? The operational processes and the data. Getting back to that organizational change management can be very important. And finally, the compliance and ethical protections, which then allows us to leverage regulated data while also doing it securely. Now, it's important to know that while I had mentioned the Microsoft Responsible AI framework, which you can see at the bottom here, there really is a responsible framework or a compliance framework for everyone, depending on the particular hosting location, environment, data technology that you're leveraging. And so I implore everyone to double check what are the various compliance frameworks that make sense within your environment and how that they should be applied. Now, one of the ways that we recommend addressing your compliance and regulatory concerns is by using Microsoft Purview. And that really allows us to take data security, data governance, and risk and compliance all together so that our cybersecurity teams, our data consumers, and our legal teams all feel confident in the measures that we're taking to operationalize our data set, have lineage and classification over it, and protect it. There's many different types of protections that Microsoft Purview will create. It can connect to Office 365 and all of their shared services, endpoint DLP, all the way down to USB drives and printers. We can connect to SaaS platforms like ServiceNow or the Google Cloud, our on-premise, including SharePoint and other data governance services. And even here you can see can connect to other clouds. And so Purview is a great solution. It provides you with a compliance score and allows you to gamify achieving the highest level of compliance within your organization. And so as we start to think about best practices for securing the Azure AI data estate, we want to balance safety and innovation. We want to have that federated governance model with robust data protections, but we still want to be agile while we're safeguarding that sensitive information. And we can do all of that with the Microsoft Azure AI platform. And we can do that with continuous monitoring and auditability. We can track those data flows from the services like Data Factory within Microsoft Fabric or Databricks pipelines and notebooks. We can have a federated governance model by distributing that authority to local teams while still having an overarching visibility of compliance across our organization. You can then have sensitivity labels and data loss protection, and those can be applied to even AI-generated content. And so as we come away from the session, I want everyone to think about some of the key questions that have been asked here. And another one of them being, how are you tracking or preventing the flow of intellectual property to external language models? And when we start to think about having a lineage of our data and where is our data sent to and received by external organizations, sending our data out to an external large language model may be a very large risk that we want to account for. And it may be something that we don't necessarily think about too much. Oh, a couple of the employees just decided to use one of these publicly available services. Well, we're considering a regulated data set that may not be allowed whatsoever. And so let's use tools like Microsoft Purview and Sentinel and Fabric to reduce that risk profile and then enable adoption within our environment and organizational change management so that users want to leverage the solutions that we've built and that they don't want to go outside and try to use services that may be just publicly available to consumers. And so, wrapping up here, we have a couple of key takeaways, right? As a part of building AI agents and your data estate is you should evaluate your data security from your pilot environments all the way to when you're in enterprise scale. And to do that, you need to have a unified vision, right? You need to have that center of excellence and that organizational adoption of a modern data estate. But that needs to be tied with clear benchmarks for success. And you can do that by creating a well-defined roadmap so that everyone is marching in the same direction while you're still holding yourselves accountable to compliance and security requirements. You'll want to integrate those AI data security goals into your broader landscape. Many organizations are creating an AI steering committee, and they may take on responsibility for ensuring that data security isn't left behind or forgotten about. We'll want to channel those resources into the high impact areas first, right? And things that we started with, like data quality evaluation, may be where they really need to focus in on. But as they're developing those solutions, make sure that real-time visibility comes alongside it so that you know how the services are performing, but you also know what security events are happening within your environment. And the way that we always recommend is to learn from pioneers in the space, right, who work with customers on a day-to-day basis to balance these cutting-edge AI deployments with these required governance and compliance procedures that each of our clients have. And so what I'd recommend is continue your AI security, data modernization, and innovation journey with Cortec. You can reach out at cortec.com/contact, and we would be glad to help you understand more about establishing a secure AI data estate, leveraging the Microsoft platforms. And we provide expertise in Purview, Azure AI agents, Microsoft Fabric, Databricks, CI/CD, and DevOps to tie it all together, as well as offering many security services to really go that extra level deeper. So I appreciate everyone's time for joining me today, and I'm glad to field potentially any questions that will come into the chat. I thank you all and have a great rest of your day. Bye-bye.